Hi everyone, this is Mrs. Snowbeck. Today we're going to do Unit 4, Lesson 4, and we're going to study the rhombus and the square. A rhombus is a parallelogram with 4 congruent sides. And you can see over here on the right, see how the sides each have a tick mark? That means that is a rhombus. All 4 sides are the same length. The plural for rhombus is rhombi. Like if you have fungus, it's fungi, or octopus, octopi. Rhombus, rhombi. And a rhombus, notice it said it was a parallelogram. So opposite sides will be parallel and congruent, just like a parallelogram. Opposite angles will also be congruent. So like angle F and angle H will be the same size, and angle G and angle J will be the same size. Consecutive angles are supplementary, which remember that means they add up to 180. So 2 angles right in a row will add up to 180, and the diagonals bisect each other. So imagine I draw in the diagonals. So from F to H there's one diagonal, and then from G to J there's the other diagonal. They bisect each other. So this and this get cut in half, and then same thing going the other way. Both of the diagonals cut the other one in half. In addition to having all of the same properties as a parallelogram, the rhombus has a couple of more properties that are unique to the rhombus. For instance, diagonals are perpendicular to each other. And remember that symbol for perpendicular? That's that upside down T. And so what I could say is segment AC is perpendicular to segment BD. A second property that is unique to the rhombus, different from the parallelogram, is that in a rhombus, each diagonal bisects the opposite angles. So for instance, let me highlight it here. I'll highlight it in green from R to P. That segment is going to bisect angle P. So angle 1 and angle 2 end up being the same size. Also, angle 3 and angle 4 end up being the same size. So 1, 2, 3, and 4 are actually all congruent to each other. And then same thing happens with 5 and 6. The other diagonal comes through here and cuts angle N in half. So 5 and 6 are the same size, and 7 and 8 are the same size. So let's list that out. Angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. Angle 5 is congruent to angle 6, and angle 7 is congruent to angle 8. And that does not happen in a regular parallelogram. Imagine your diagonal. This angle down here is not the same as that angle there. Number 1, given quadrilateral ABCD is a rhombus, find the following. If the measure of angle BCD is 64, so BCD is 64. Does that look like 64? Not even close, but I guess we have to go with it. Find the measure of angle BAC. BAC is this angle in yellow up here. So what I'm thinking is the 2 angles across from each other, right here and right here, angle A and angle C, those are going to be the same size. And then the diagonal comes and cuts that in half. So if over here is 64 degrees, then over here is also 64. But we're going to have to cut that in half. So 64 divided by 2 is 32 degrees. Part B. AB is 2x plus 3. So the distance up here is 2x plus 3, and B to C is x plus 7. Find C to D. Find this one. Well, in a rhombus, remember, all 4 sides are congruent. That's what makes it a rhombus. And so the 2x plus 3 equals the x plus 7. Now what I can do is I can solve this for x. And I wind up with x equals 4. And then I'm going to take that 4 and I'm going to plug it in right here. So 4 plus 7 is 11. In other words, this side is 11, which means CD is also 11. So CD is 11. Now let's move on to a square. A square is a rhombus with 4 right angles. So remember, a definition of a rhombus is that it's a parallelogram with 4 congruent sides. So a square is a rhombus. So it has all those same properties that a rhombus and a parallelogram have. Opposite sides are parallel and congruent. The diagonals bisect each other. The diagonals will even be perpendicular. Imagine I draw in these diagonals. They're going to be perpendicular because the square has all the properties that a rhombus have. Let's take a look at this Venn diagram. Let's think about some of the types of quadrilaterals we've learned about. We've learned about parallelograms. Parallelograms are quadrilaterals with 2 pairs of parallel sides. Now, can you think of a type of parallelogram that has right angles also? If you're thinking rectangle, you're right. A rectangle is a type of a parallelogram, but it also has 4 right angles. Can you think of a type of parallelogram that also has 4 congruent sides? A rhombus. So a rhombus has 4 congruent sides. Is there something that has both? Is there a parallelogram that has 4 right angles and 4 congruent sides? You bet. The square. So the rectangle, the square, and the rhombus are all different types of parallelograms. Number 2, the diagonals of rhombus WXYZ intersect at V. Use the given information to find each measure or value. If the measure of angle WZX, okay, let's find that, WZX. So we're talking about this angle right in here. That is 39.5 degrees. Find the measure of angle ZYX. Let's trace that. ZYX. So they want us to try to find out this blue angle. Well, remember, if this is a rhombus, this little corner down here will also be 39.5. So 39.5 times 2 is 79. Now think about if let me highlight it in a new color. Let me highlight it in yellow. This over here is 79 degrees. So consecutive angles are supplementary. So what if you do 180 minus the 79? You're left with 101. So in other words, that's the measure of angle ZYX. 101 degrees. That's the blue one over here. Consecutive angles add up to 180. Okay, next, part B. WX is 8x minus 5. WZ is 6x plus 3. Find x. Well, this is a rhombus. It tells us that at the start. So all 4 sides are congruent. And so 8x minus 5 equals 6x plus 3. Solve for x. X equals 4. And we're done because it doesn't say to plug it back in, so we can be done. X equals 4. Go ahead and pause the video. Try number 3 on your own. When you're done, unpause the video. So WT is 3. I'm just going to put that on here. It does say it's a square. So diagonals bisect each other. And that would mean from Y to T is also 3. But in a square, since it has the properties of a rectangle, it also has congruent diagonals. And so a square is going to also have these be 3 and 3. They'll be the same length. So WY is going to be 3 plus 3, which is 6. From T to Z, that's going to be 3. You can see it already marked on there. Find the measure of angle WTZ. So WTZ, if I trace it, is this angle in here. And I believe since it's a square, those diagonals are perpendicular, so that is 90 degrees. And then last but not least, find the measure of angle WYX. WYX is this angle. Well, remember, a square has all the properties of a rhombus and a rectangle. So the corner at Y is 90 degrees, but it's going to get bisected into 45 and 45 because it's also a rhombus, or has the properties of a rhombus. So our answer, 45 degrees. Great. Will you guys please try Unit 4, Practice 4? If you have any trouble, just send me a Schoology message. Have a great day.